IIT Delhi, the place where the students get exposure and the training which is enough to handle any national, international or professional project. The unique facility and available advanced technology in the campus gives broad exposure to students to test and validate the research and projects. Hence, Team ALTRUIST decided to make the purposed structure in campus itself. Before real construction, the team wanted to prove the reliability of the idea, design, concept, and decided to prepare a scaled-down model. The dimensional ratio was taken as 1:8 and construction procedure was same as that in original concept. The materials used consisted of wooden sticks, rubber strips and rope so that the basic design is conceptualized. Mr. Chaurasia, the lab in charge of Strong Floor Lab, helped the team by guiding them for testing of the model. The shake table configured with MTS system has been used to measure the frequency and amplitude for a given input. These parameters define the Richter scale with continuous variation in frequency and amplitude. It was found that the structure was light and strong enough to bear the live earthquake loads. On the second day, Team ALTRUIST started to build their actual structure. The bar was used to dig the soil at the site. The dimension of each bore was 7 inches in diameter and 13 inches in depth. 4 rocks in each bore were put by the side of lumber to act as a shock absorber and provide earthquake resistivity. The earth is ramped using the same bar. Constraints and amount of rubber required for the contest, team decided to buy retail rubber spool from the market, which is standard raw material for tire tubes. Strips were cut of 3 cm width and tied with the frame horizontally and vertically to weave the grid, which is strong enough to bear the dead load of weight above it without appreciable deformation.